Hello friends, you are watching This is Awesome Videos, and today we are going to solve one numerical on the based on maxima and minima. Okay, this type of sums are regularly asked in the JEE mains and advanced. So let's see how it's going to be asked. Okay, so this is the sum of application of derivative type, and the subtopic is maxima and minima. So the thing which we have learned in the previous lecture, today we are going to use it in this sum. Okay, so what's the question? Here you can see one box is given and the dimensions are also given x, and y. How to applicate the derivation here is asked in this question. Okay, here the base is x, the length is x, and the height is y. Okay, here it's given square base x and a variable y height. Okay, so and the total surface area of the box is given, it's 48. 48 is the total surface area. Now it is said that the box is open from the upper part. So you can see here it has 5 phases. Which 5 phases? I marked here by using pen. You can see this. Which 5 phases? This is 1, this is 2, this is 3rd, this is 4th, and this bottom one is 5th. So this 5 phases. Now, so we have to calculate the surface area. We have to make an equation so that we can find the maximum and minimum value of the function. What is given to us? It's the surface area. Surface area is 48. Now what we have to do? We have to equate the variables using the real value. Real value is 48. It's a surface area. So what is the surface area? Surface area is total surface area is area of base plus 4 times area of one side. Area of this base and 4 times area of this and this. So area of one side. So that's equal to x square plus 4 into xy. How? Because the base is x square, so that area is x square, and for this phase area is xy. So our equation becomes like this: 48 is equal to x square plus 4xy. 48 is equal to x square plus 4xy. Now 4xy is equal to 48 minus x square. So I have here you can see it's two variable, x and y both. So what I do, I just convert it into one variable. 4xy is equal to 48 minus x square. So y is equal to 48 minus x square by 4x. So by separating this denominator, I can find this equation: 12 by x minus 1 by 4 into x. Okay, this is the equation of this box in the terms of y and x. Now what's our aim? What's the question? The aim is we wish to maximize the total volume of the box. What is our aim? We wish to maximize the total volume. So by given this particular surface area, is equal to 48, what I have to select the dimension of x and y so that the volume is going to be maximum. Okay, so what is the volume of this box? You know, for the cuboid or cube, the volume is height into length into width. So here x into y. So our volume is length into width into height is equal to x into y, that is x square y. Now we all know that if we want this quantity as maximum, we must have to differentiate it. So we are going to differentiate it. But as we see in the previous lecture, the variable should be one. There must be one variable. But here there are two variables, x and y. So we have to put the y in the terms of x. We found that y is equal to 12 upon x minus 1 by 4x. So what's the trick? The trick is we have, if there are 3 or 4 variables, you have to convert all the variables into the one variable, so you can differentiate it and get the answer. Okay, here are two variables, so I convert y in the form of x and put it down here. Here the volume is x square y. See, here the volume is x square y, and I put it down here x square, and y is equal to 12 minus x minus 1 by 4 into x. Now I'll just simplify this, x square into this, so 12x, it's minus 1 by 4 into x cube. Now what I have to do, I just have to differentiate it. By differentiating this, that means v dash is equal to 12, x differentiation 1 minus 1 by 4 is common, x cube differentiation is 3x square. So what we do for maximum finding and maximum and minimum value, we have to equate first derivative is equal to 0, so this becomes equal to 0. I just simplify this, I just common out the 3 by 4, so here it comes 16 minus x square. Now 16 minus x square I can write like this, 4 minus x into 4 plus x, a minus b into a plus b is equal to a square minus b square. So by this I get my two values of x. So x is equal to 4 or x is equal to minus 4. Now see friends, here you don't have to go for the second derivative, because the only option for x is equal to 4 is valid. X is equal to minus 4 is not valid. Why? Because we are talking about length. X and y, these are the lengths. A length cannot be negative. So here x is equal to 4 is the only possible value. So x is equal to 4. So what's the value of y? For finding the value of y, we have to put x is equal to 4 in this equation. Let's put here. So x is equal to 4 I put here. So it's 12 by 4, it's 3. 3 minus 1 by 4 into 4, it's 1. So 3 minus 1 is 2. So we found y is equal to 2. So x is equal to 4 and y is equal to 2. By using this quantity, we can get the maximum value by this surface area, 48 surface area. So but what's that volume? For finding that particular volume, we have to put x and y in the form, in the which equation? In the volume equation. And the volume equation is this, x square into y. So put x is equal to 4 and y is equal to 2 in this equation, and we get the value x square y. 4 square is 16 into y is 2, so 16 into 2 is 32 feet cube, because volume's unit is feet cube. Volume is cubic equation, so its unit is feet cube. Okay, so this type of questions are asked in the application of derivative. This may be asked in JEE portion, this may be asked in your regular board exams. You just have to do one thing, you just have to make an equation, and you have one aim. In the aim, if there are two variables, if there are three variables, convert all the variables in one variable, one common variable. You can convert x into in the terms of y. Okay, this is possible, but here I convert y in the terms of x, and differentiating that you can find the maximum quantity. Okay, so this is the numerical based on maxima and minima concept video. If you like this video, don't forget to share it and subscribe, that hit the subscribe button. Thank you.